So we're going to start by evaluating the integral of 1 over x squared minus 7x plus 10. There are a couple of lessons in this example. The first one is if you watch the introduction, you've seen that we treat quadratic factors and linear factors differently when they appear in the denominator. So the first thing you want to recognize is that this is not a quadratic factor. I know it looks like one, but it's actually a pair of linear factors. Why is that? The reason is that if we start this, we can see that x squared minus 7x plus 10 is equal to x minus 5, x minus 2. In other words, I can factor it. So let's be clear on something. When we talk about quadratic factors in using this method, we are talking about irreducible quadratic factors. Like, for example, x squared plus 5 cannot be factored. There's no way to factor that using the real numbers. A little later in this course, we may get to a topic where we use the complex numbers to factor that, thereby allowing us to find, a different type of solution to this sort of problem. But for now, we are dealing strictly with the real numbers. And so the first question you have to ask when you look at the denominator is, can it be factored into linear and quadratic factors? Um, so so this one can. So what we want to do is we want to write this as the antiderivative of x minus 5, x minus 2. So this is now, it's now just as if we had been given this problem where we have two linear factors in the denominator. The denominator is a product of two linear factors, rather. So what I want to do is I want to set this up the following way. I want to say that a over x minus 5 plus b over x minus 2 is equal to 1 over x minus 5, x minus 2. So this is based on the introduction where we saw how different types of rational functions decompose. We can see that this is in fact the correct decomposition. We simply have to solve for a and b. So the way we're going to do that is we're going to multiply everything through by the full denominator. In other words, I'm going to multiply both sides of the equation by x minus 5, x minus 2. That gives us a x minus 2 plus b x minus 5. And no, I didn't make a mistake there. When I took a over x minus 5 and multiplied it by x minus 5, x minus 2, well, we'll do it in the same order, x minus 5, x minus 2, these canceled out, giving me a x minus 2. So that is the correct decomposition. I did write that correctly, and just erase this here. And this is, this factor next to the b is also correct. When I multiply the right side by the entire denominator, I just get 1. So now what I have to do is solve for a and b. The simplest way to do this is to zero out one of the factors. In other words, if this equation is true, it should be true for all values of x. So what I'm going to do is I'm going to let x equal 5. Let's write that here. Let's let x equal 5. If I do that, then what I get is a times 5 minus 2 plus b times 5 minus 5 is equal to 1. That gives me a times 3 plus b times 0 equals 1. And from this I can infer, so I have 3a equals 1, so a is equal to 1/3. Now let's do the same with 2. As in other words, we'll use the same technique to solve for b. So let's let x equal 2. That gives me a 2 minus 2 plus b 2 minus 5 equals 1. So I have now a times 0 plus b times negative 3 equals 1. So all I have left is negative 3b equals 1, which gives me b equals negative 1/3. By the way, when you solve these problems, what I'm doing here is a very good technique. As you deduce what the constants are, just put boxes around them because it'll remind you of what you've solved for. It's actually fairly important because these problems do get kind of messy. So, all right, so we now have the constants. So what I can now say is that the antiderivative, the indefinite integral of dx over x squared minus 7x plus 10 is equal to the integral of, I've decomposed it into a over x minus 5 and b over x minus 2. So that's going to be 1/3 over x minus 5 and then minus 1/3 over x minus 2. And we'll put a dx after that. We know that we can break this up, so this is just going to be the integral. This is going to be, let me break it up by the linearity rule. So that's going to be 1/3 integral of dx over x minus 5. and then minus 1/3 integral of dx over x minus 2. So I can now just integrate these separately. We know how to integrate functions of the form 1 over x minus plus or minus a constant. So this is going to be 1/3 ln x minus 5 minus 1/3 ln x minus 2, and we add a plus c, and we're done. And that is the integral, the indefinite integral of the given function.